Hey everybody, Mr. Mack here. Really excited to graph a new one with you, and I'm really enjoying using my Energel liquid gel ink. I give it a thumbs up. All right, so I'm going to draw Root X. Now Root X is really cool. The first thing I notice about Root X, of course, is that there's an extreme domain restriction. This function doesn't even live anywhere to the left of 0. So I am going to, just going to fill in my gaps here. All right, what I'm going to do is I am going to realize that root x only exists when x is greater than or equal to 0. So I'm actually going to build like a wall right here. So I'm like at 0, nothing exists to the left of 0. Okay. But root x equals 0 at 0, so I know it's going to be at 0, but then whatever positive values I stick in here, the square root of a positive number, of course, is positive, so it's always going to be positive. But here's the thing. Now I realize if I'm right of 0, it's going to be positive. This is going to be an extremely first quadrant centric picture, right? All up here. Okay. First derivative. We know the derivative of of root x is 1 over 2 root x, and 1 is 1 over 2 root x equal to 0. Well, it's not. It's not at all. It's never equal to 0. But I realize that x cannot equal 0. So I'm going to do like a dashed line and say there's some sort of problem, but because the function wasn't even there to begin with, I'm also going to fill that in as like a no man's land sort of thing. All right. Now, if I were to plug in any positive value into 1 over 2 root x, it's always going to be positive because 1 divided by 2 times a positive is positive. So now I know this entire graph up here is going to always be going up. But it's going up from a problem, right? There's some sort of issue right here. All right, that's fine. We'll figure that out in a second. So coming up from a problem or from a beginning or something like that, there's some sort of non-differentiability here at the beginning. So maybe it's like a vertical tangent, or like it wouldn't be a corner because nothing comes from the other side. So it's probably like a vertical tangent. Okay. My second derivative, of course, I can't have a second derivative existing where a first derivative did not, right? So I'm going to put another wall and a problem at 0. You can't have something existing under nothing, right? I mean, it's not like you're going to have a real foot on the bottom of a wooden leg. So all I'm going to do now is take the derivative of this. Now this is an issue because I don't really want a quotient rule. I don't really want a 1 over something. So I'm going to rewrite this as 1/2 x to the negative 1/2 because it is. And I'm going to just use the old power rule to take the derivative of that, and then I'm going to rewrite that as negative 1 over 4x to the 3/2. But when is that equal to 0? Well, it never is. But then I realize that x cannot equal 0 again. I already knew that. So now, if I'm going to put in any positive number, now any positive number raised to the 3/2 is any positive number cubed and square rooted, or square rooted then cubed. But it's going to end up being positive. And a negative divided by a positive is going to end up being negative. So no matter what I put into here, it's going to be negative. So I have to be above, going up, concave down from a problem. But above, going up, concave down only has to look something like this. So I know since I'm starting at 0, 0 from a vertical tangent, some sort of problem, continuing to go up, concave downly must look something like this. And there is root x.